Hi folks, we're going to take a look at number 13 on page 434. So they give us this line in 2D given to us in parametric form, and they give us the equation of a circle, and they ask us to find the points of intersection A and B between this line and this circle, and then they want us to find the length of the chord joining AB. So here they essentially tell us that there will be points of intersection, but if you think about it, if you've got a circle happens to be centered at 0, 0, and you realize you have three possibilities. There could be no intersection, there could be a single intersection if the line is tangent, or there can be two intersection points. Okay, and this type of scenario should make you think that at some point you'll be solving a quadratic equation. Okay, so when we're finding points of intersection, we're usually solving a system of equations. So essentially that's what we have here, a system of equations. So it doesn't look like elimination is going to help us out, but I think substitution can, because here we need this x and y to be the same as the x and y from points on the line. Okay, so what I can do is I can substitute this x value for the expression representing x from the line, which is 2 plus t, same thing for the y value. Okay, so let me do that substitution. So this gives us 2 plus t squared plus 9 plus t squared equals 169. Okay, and we get exactly what we expected, which was a quadratic equation in t. Okay, so now we just got to do the algebra. So this gives us 4 plus 4t plus t squared. Okay, and here we have plus 81 plus 18t plus t squared equals 169. So here we have 2t squared. 4 plus 18 is 22, so 22t. Here we've got 81 plus 4 is 85 minus 169. I don't feel like doing that in my head, so let's just be sure here. So what do we got? 4 plus 81 minus 169, and we've got minus 84. Okay, I can simplify this equation by dividing both sides by 2. So this is t squared plus 11t minus, this is going to be 42, equals 0. So let's see if we can factor this. So 6 and 7 is not going to work, but we've got 3 and 14 is going to work. Yeah. Okay, so here if we have t plus 14 times t minus 3 equals 0. 14 minus 3 is 11. 14 times 3, 42. So we are good. So that means that t is equal to negative 14 or t is equal to 3. So this confirms that there's going to be two points of intersection. Okay, so let's start by calculating those points. And here, since we have t values, let's input it into the line equation. We know we can input it into either one. So here we have x is, I guess we'll call this a. X is equal to negative 14 plus 2 is negative 12, and y is equal to 9 minus 14 is negative 5. Okay, and then point B, x is equal to 3 plus 2 is 5, and y is 9 plus 3, which is 12. Okay, and you can do a quick check. If you do 5 squared plus 12 squared, you are going to get 169. Okay, so these are our 2 points. Okay, I guess technically we should write them out as coordinates. So negative 12, negative 5, and B is 5, 12. Okay, now in the next one, in B, we just have to find the length of that chord, and we can find the length of that chord by either using our distance formula or think of it as the magnitude of the vector joining those two. In the end, gives us the same thing. So the length of AB, so AB here is equal to, I guess the length of AB, so it's just going to be square root of 5 minus negative 12, 17, and here plus 12 minus negative 5 is also 17. So here, what do we have? We've got 17 squared plus 17 squared is equal to 578, which I do not believe is a perfect square, and it is not, so it's around 24. And leave it there. Okay, so there we have it. So just to recap here, Here we're solving a system of equations because we're finding a point of intersection. So in this case here we were able to substitute the expression for the x and y values from the line into the x and y variables of the equation of the circle, and we end up with a quadratic equation which gave us two solutions. Okay, that's it for this one.